Welcome to one more Flip Classroom math video. 3 tips before you start. First, you could slow down or speed up the playback if that helps you watch the video at your own pace. Second, you could pause the video anytime to jot down notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. Today's lesson covers creating the function when you're given the graph or information about the graph. So you're starting with the parabola and you're being asked to create the function. Now we don't just draw the curve on the graph and ask you to do that. We also give you a little bit of information because otherwise you couldn't. So here's a graph. Check it out. We have our intercepts, 2, 0 and negative 1, 0. And we also have our y-intercept, 0, 2. Okay? So the way we're going to do this is we're going to use these 3 data points in factored form to come up with our function. So let's get started. So the first thing and the easiest thing is to put in my intercepts. So check this out. We're going to get f of x equals a times x minus m. Now m is minus 1, so that's going to be x plus 1, and x minus the n, which is 2, so this is going to be the minus 2. So there's my factored form. Now, I need a. I don't know what a is going to be. So to do this a function, I need my a term. Now, fortunately, I have a third point here. I have the y-intercept. So that's got to satisfy this equation as well. So when x is 0, y is 2. So what I can do now is I can plug this point into my factored form and solve. So I'm going to write out a few steps for you. Hang on just a sec. Okay, I spelled that out with a few more steps for your notes. I'm sorry you're going to have to change your notes, but take a minute to get these in there. That means that when you review your notes later, it'll make a little bit more sense about what's happening. So quickly, to review, the first step is to plug the x-intercepts into factored form. So I went ahead and rewrote that step for you here. The second step is plug a third point in to find a. Now, in our case here, that third point is our y-intercept, but if you knew other points on this function, it could be any other point. So let's do that. So f of x for this point is 2. We know the y value at 0 is 2. So this is going to be 2 equals, now I don't know a, but I do know my intercepts, right? So it's going to be 0 plus 1 times 0 minus 2. So all I did is I plugged the 0 for x into my function where x exists. So now I have an equation that has one variable. We can always solve that. So let's take some steps here. This is going to be 2 equals 0 plus 1 is just 1. So we have a times 1 times minus 2. So here we get 2 equals negative 2a. Divide through by negative 2. And we get a equals negative 1. So now that we found our a, we can write the function. Okay, the last step is to take your function and write it in standard form. So I went ahead and reproduced our function as we had it at the end of the last step. So I have minus 1 times x plus 1 times x minus 2. Now the trick is that we're just going to expand. Now the thing is that we need to distribute this negative 1 on here to make this correct. So what we're going to do, or this is just one way, we're going to get minus x minus 1 times x minus 2. Now I'm going to FOIL that. So minus x times x is negative x squared. Minus x times minus 2 is plus 2x. Minus 1 times x is minus x. Minus 2 times minus 2 is plus 2. So then we're going to get equals negative x squared plus x plus 2. And that's our function, f of x equals, there you have it. So let's do a similar example, but this time we're going to use the graphing display calculator and the regression feature to generate the equation. Now you can do this on almost any problem, and remember we mentioned before that there's a calculator portion and a non-calculator portion of your test. Actually, if you're in the applications and interpretations IB class, then you can use your calculator on all of the tests. But there's a caveat. If you have a question that says show that something is true, you're going to need to show algebra and steps that show that. You can use your calculator first to get to the answer and then reverse engineer the steps. That will be fine. But if you use your calculator and put the answer down and don't show steps, you're not going to get all the points. So you're not off the hook for the algebra of the type we did on the last board. But this time we're going to skip that algebra and we're going to use the graphing display calculator to get the function, to get the equation. So let's get started. So quadratic regression on the GDC. A regression is just a computer tool that will take points that you give it and come up with the line that best fits that point. So you can do scatter plots and things like that. In this case, our best fit line is going to be a perfect fit because the points do fall on a quadratic equation. And we're just going to ask the computer to find that for us. So pretty cool. So here's how you do it. You do need 3 points. 2 points does not describe a parabola or a quadratic, but 3 can. So check this out. What we're going to do is we're just going to enter the x and y values into the calculator in a spreadsheet, and then we're going to use the menu system to perform a quadratic regression. And it's going to spit out the functions. Pretty cool. I'll be in the emulator in just a second to show you how that works. But here's the problem that you might get. Here's a quadratic sketched out for you, and you have 3 points, all 3 intercepts. We've got -4, 0, the y-intercept is 0, -12, and the second x-intercept is 2, 0. So let's jump over to the calculator and see how that works. Okay, here we are looking at the emulator screen. Again, to orient you, here's the full calculator on the left. This is fully functional. You can press all these buttons, and then it just has a blow up of the scratch pad of the screen. So the first thing we're going to do here is create a new document. So I'm just going to click the new document button, and then what I'm going to do, the document I'm going to create is a list or a spreadsheet. When I click that, here I have a little spreadsheet. Now on the top, you want to label your points. In this case, we're just doing x against y. But if you were doing data where you had like year and population, or if you had temperature versus time, or any number of things, you can go ahead and type in whatever those variable identifiers are. Okay, so now let's take a look at our points. Our first point was -4 and then 0. That was the first y-intercept. And then our second y-intercept was that first one is our first x-intercept. Our y-intercept was 0, -12. And then our second x-intercept was 2, 0. So there we go. I've got my 3 points from my function sitting here in the spreadsheet. Now, the interesting thing I can do here is I can insert a new document and have it show a graph of these 3 points. And the trick for that is you click Control Doc, it brings up new document, and we're going to add a data and statistic. Now, this might not seem like data and statistics are about quadratics, but it will work out that way. Generally, regressions are done on statistics, but you can also do them on quadratics. Regressions tend to be associated with statistics. I'm going to go ahead and click that. And here we go. Here's those 3 points. Now, they're just kind of sitting there. It's sort of hard to tell what's going on. But if I click down here to add a variable, I can tell it that the horizontal axis is x. Notice how now we've scaled our horizontal axis. To make the picture complete, we're going to tell it that the vertical axis is y. And there we have our plot. And you can see pretty much now that those are the 3 points that were on the graph we had on the whiteboard just a minute ago. We don't know what the parabola is. Fortunately, this is super easy. I'm just going to hit my menu. I'm going to go to Analyze. I'm going to go to Regression. And then I'm going to go to Show Quadratic. When I click this, presto, let's drag this equation up. There's my equation. Now, that couldn't be simpler. If you're working on the TI-84, I'll put a link to a video on YouTube that shows how to do this on the T-84. Okay, let's jump back to the whiteboard. Because I know that algebra works best with practice, I'm going to turn you loose on the same function. I reproduced it over there, but I want you to use intercept form and that algebraic process that we just went through. Okay, so if you follow along with your calculator on the last section there, you know how to do this on your calculator. But my guess is a little more practice with the algebra is not going to hurt. So here we go. You've got your intercept or your factored form here. You've got the 3 points, your 2 intercepts there, and your y-intercept down below. So go ahead and pause the video, consult your notes from the last time we did this, and see if you can wind up with the same function we just found on the graphing display calculator. Okay, let's see how you did. First step, let's plug in my intercepts. So f of x equals a times x minus that number. So that becomes x plus 4 times x minus that number for the other x-intercept. Okay, so now we have our function or our intercept form without our a. So now we can take another point, namely this one, and plug it in where it belongs and we can find our a. So at the point 0, negative 12, f of x is minus 12. That's going to equal a times 0 for the x plus 4 and 0 minus 2 for the x. So what we're doing is we're plugging this point at the point 0, negative 12. The x value is 0, and the equation resolves to minus 12. And in this way, we can find our one remaining unknown, which is the a term. So let's work this. Minus 12 equals a times, this becomes just 4 times minus 2, and that's just going to become negative 8a. So we have minus 12 equals negative 8a. We're going to divide through by negative 8, and we're going to get 1.5 equals a. Okay, so that's good. Now we know our a. Now we can go ahead and plug our a back into this form and solve it to put it into standard form. So go ahead and pause the video and do that if you haven't done that already. Okay, I reproduced what we wound up with before down here, further up so we have more room, and I'm just going to go ahead and work this. So my way is to go ahead and multiply this 1.5 times these two terms. You could also FOIL these and then multiply 1.5 times all three. Either way should get you to the right place. So let's do this. We get 1.5x plus 6. 1.5 times 4 gives us 6. And then we have x minus 2 from there. Now I can just go ahead and FOIL. We get 1.5x squared minus, so what's 1.5 times 2? That would be 3. So that's minus 3 plus 6x. And minus 2 times 6 is plus 12, or minus 12. Oops. Now right away I know I'm on the right track because this minus 12 is the y-intercept, and that's what we have there. So always look for confirmations as you work. Let's finish this up. F of x equals 1.5x squared. Now minus, that is this should be a 3x. I hope you caught that. So I have minus 3x plus 6x. I have plus 3x minus 12. And that indeed is the function that we found on the calculator. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.